compound interest. So the two formulas you gotta have in your notes. One is to figure out how much money you're gonna make if it compounds, like yearly, monthly, quarterly, and that is equal to the amount you deposit multiplied by 1 plus the rate divided by the number of times you compounded a year raised to the n times t, so how many years you leave it in the bank. So number one, 25 grand, that's what we're going to deposit, that's our P. This is our interest rate monthly, that's our N. So we're going to collect interest, we're going to get paid interest 12 times a year. You're now 18, you're going to leave that money in the bank until you're 65. So that's our time, and our time is going to be 65 minus 18, that's 47. Alright, so how much is your A is going to be pretty easy, just plug them all in. So the money we're going to have at retirement is equal to 25,000 multiplied by 1 plus, okay, the rate, you got to change it to a decimal, so you need to move it over 2 times to the left, 0.045 divided by n, monthly is going to be 12, and you're going to raise this all to the 12 times 47. So now, just type that in a calculator, press enter. So let me pause it and calculate it. Okay, it comes out being $206,421.48. And now B, you're bummed because that's not as much money as you had hoped for. How long is it going to take for you to grow it to $1 million? So now we're going to not solve for the money, we're going to substitute $1 million in for the money, and we're going to solve for t, we're going to solve for time. So 1 million is equal to 25,000 multiplied by 1 plus 0.045 divided by 12 raised to the 12 times t. Okay, now this is a good problem. We got to solve for the variable, and our variable is in the exponent. So we got to undo everything that's hanging out with this variable. We got to undo this 12. We got to undo everything in the parentheses. We got to undo this 25 grand outside, and that's what we're going to undo first. Let's undo this 25 grand. So let's divide both sides by 25 grand. Divide this side by 25 grand, and that's going to be 40 is equal to 1 plus 0.045 over 12 raised to the 12 times t. I'm going to calculate this. What is 1 plus 0.045 divided by 12? Okay, so I've got 40 equals, that's 1.00375 raised to the 12t. Okay, now I gotta ditch this base first. I gotta ditch the 1.00375, and the only way you can undo a base is by the logarithm. So we gotta morph this power into this exponential equation. Let's morph it to a logarithmic equation. So it's going to be log, and this is my base, this 1.00375, and we're going to take the log of this base of 40, and that's going to equal the exponent, which is 12t. So now on my calculator I type in the log of that base of 40 and hit enter and change that to a decimal, And then I just got to, last step, I just got to divide by 12, divide this by 12, divide this whole side by 12. So on that number I got divided by 12 is going to give me t is equal to 82.1287 years. So if I want it to grow to $1 million, I got to leave it in there, not touch it for 82 years. Okay, the last one, your broker tells you that if you give him more money, so if you invest 35 instead of 25, he'll give you a better rate and he'll compound it continuously. So you're getting interest paid every second of the day instead of once a month. So the continuously paid interest is equal to the amount you deposit multiplied by E raised to the R, the rate times how many years you're going to leave it in. So the P is 35 grand. So 35 grand, multiply that by E raised to the, change that to a decimal, 0.07, multiply that by, I can't remember what it was, how many years was that, 47 years? I think it was 47. Okay, so now just calculate that, type that in your calculator. And this one you're going to get more money. So the money you're going to get is almost $1 million. 939,523 cents. So if you can come up with an extra 10 grand to give to him, that's well worth it. Okay, number 2 is another equation that's going to require logarithms to solve. So you're given the formula right here, and we're given all the numbers. We got to figure out what to plug in. So 150, that is our initial temperature. That's T sub 0. 10 minutes, this is going to be the time, so we're going to plug that in for T. Oh, maybe not. Maybe this is different. Yeah, your test is different. Okay, 10 minutes, and the temperature has cooled off by 20 degrees. Now you decide to crunch some numbers to figure out mathematically when you're going to be able to eat the soup. You look at the thermostat to find the room temperature to be 72. Okay, we gotta find K. So, here we go. We started off with the soup being 150, so that's my initial temperature. This formula gives you the temperature of the soup based on time, based on how many minutes has passed by. So the new temperature of the soup is 130 because it's cooled off by 20 degrees. So 130 equals the temperature of the surroundings, so that's 72 degrees, plus the initial temperature minus the surroundings, and you're going to times that by E raised to the negative K, and that's, we don't know K, but we do know T, that was 10 minutes. So I know everything except for K. So let's figure out what K is, but now we got to undo everything. Let's undo this 72 clear out here. Let's minus 72, minus 72. So we got 58 is equal to 150 minus 72. It's going to be 78. Multiplied by E to the negative 10K. Alright, now let's ditch this 78. Let's divide this by 78, divide this by 78. So, if we've got this, if we've got 58 over 78 equals E to the negative 10K. Now, we got to solve for K. So we got to ditch this E, we got to undo the base. The only way you can undo a base is by a logarithm. So it's going to be log in base E of 58 over 78, and that is equal to the exponent, a negative 10K. So on my calculator, I punch in log in base E here, that's the natural log, so just ln ln of 58 over 78 and hit enter. That will give you a decimal value that ends up being like a negative 0.296. But now we just got to divide by a negative 10. So divide that whole decimal by a negative 10. Divide this by a negative 10 and we get k is equal to 0.0296. We want 4 decimal places. So this is the k. We're going to have to use this. 0.0296. So now k equals 0.0296. KB, use k to figure out the temperature of the soup after 15 minutes of sitting on the counter and cooling off. So now this is what I want to find, the temperature of the soup. So the temperature equals the surrounding 72 plus the initial, which was 150, minus the surroundings, multiply that by E to the negative k, so negative 0.0296 times T, and now that's going to be 15. So B is much easier because there's nothing to solve for. I just plug everything in the formula and it spits out the temperature. Okay, this spits out 122 degrees, 122.034. So now C is going to be a little bit harder because C wants us to calculate the time. When is that time? How much time passes before it cools down to 100 degrees? So time is going to be up in the exponent, and the only way you can solve a variable if it's in exponent is through a logarithm. That's the only way to undo the base. So 100 degrees So 100 degrees equals 72 plus 150 minus 72. Multiply that by e raised to the negative 0.0296 times the unknown times time. So let's undo everything as much as we can. So this one's just like the first one, except for instead of solving for k, now we're solving for t. So minus 72 minus 72. And then let's undo this 150 minus 72. So you're going to have 28 is equal to 150 minus 72 is 78 times e to the negative 0.0296 t. So let's undo this 78. Divide by 78. Divide by 78. So 28 over 78 is equal to e to the negative 0.0296 t. And now let's undo this base of e. So let's do a log. Let's do the log in base e of 28 over 78, and that is equal to a negative 0.0296 t. And now let's get the t by itself. Divide by negative 0.0296. Divide this by negative 0.0296. And let me calculate that and see what it is. 28 over 78 divided by negative 0.0296. So t is going to equal, it's going to be about 34.6 minutes before that soup's going to cool down if it just sits there. Okay, number 3. Let's solve for x. So we got to undo everything. Let's undo this divide 2. So let's times by 2 times by 2. So we got 6e to the x plus 4 equals 6. Undo the plus 4 minus 4 minus 4, so 6e to the x equals 2. Undo the 6, divide 6, divide 6, so e to the x is 1/3. Okay, now the only way you can undo e is you gotta do a logarithm, so it's gonna be log in base e of 1/3, and that is equal to x. And log in base e is the same thing as ln. So ln of 1/3 equals x. So x equals just 1 times the ln of 1/3. Number 4. Condense these two logs into a single log by using the log properties. So, move number 1. This 5 needs to be put as the exponent of x, and the 10 needs to be put as the exponent of y. Alright, now, since these logs are both in base 2, we can combine them, and addition is linked to multiplication. So if we want to write a single logarithm, it's going to be log in base 2 of x to the 5th multiplied by y to the 10th. And then number 4, you're given a single logarithm, but you need to expand it using these same properties. So move number 1, take this 3, take it to both exponents. So it's going to be log in base 4 of x to the 3 over y to the 9. And now division is linked with subtraction. So my next move is going to be log in base 4 of x to the 3 minus log in base 4 of y to the 9. And then your last move, take these exponents and move them out in front and multiply them to the logs. So it's going to be 3 multiplied the log in base 4 of x minus 9 times log in base 4 of y. Okay, number 6. Let's morph this to a log. So 9 raised to the 4x is equal to 12. So it's going to be log in base 9 of 12 equals 4x. And then divide that by 4, divide that by 4. So x is equal to log in base 9 of 12, that whole thing divided by 4. But these are all log in base 3. So you can either change the base, which we'll do in a couple problems. So you can change the base, or you can change this 9. And this 9 is a power, it's 3 squared. So if you change 9 to 3 squared, that's 3 squared to the 4x equals 12. So this is kind of a legal move. Now, because 3 squared is the same as 9, so I'm just substituting that in its place. 3 squared to the 4x is the same as 3 to the 8x equals 12. Now if you morph this, it's going to be log in base 3 of 12 equals 8x. And then we want to ditch the 8. So divide by 8, divide by 8. So this is what we're looking for. We're looking for log in base 3 of 12, that whole thing divided by 8. And that is the same thing as b. That's the same as timesing the whole thing by 1/8. So dividing the whole thing by 8 or timesing the whole thing by 1/8, that's the same thing. Okay, 7, this is where we're going to change your base. So right now we've got log in base 4 of 5. And we can change it to any base we want really simply. So common log and a natural log. Common log is base 10 and natural log is base e. So if we want to change this to base 10, it's going to be, you can take this single log and rewrite it as a quotient. So log in base 4, I want the new base to be log in base 10. So I take log in base 10 of 5 on top and log in base 10 of 4 on the bottom. So the old base goes on the bottom. Now if we want to change it to a natural log, so log with base e, it's going to be log and base e on top, log and base e on bottom. But the 5 goes on top and the 4 goes on bottom, and they're going to show up like this: ln of 5 over ln of 4. Number 8. So a circle's got a diameter of 20 inches. So through the center is 20 inches, and it's divided into 8 equal sectors. So 4 on top, 4 on bottom. What is the perimeter of each sector? Okay, each of these radii is going to be 10. So if you're looking at a sliver, it's going to look like this. That's 10, that's 10, and then that part of the circle. And this is a 45-degree angle. So to find the perimeter of the pi, we're going to add this 10 to this 10 to this arc length. Now arc length, that's radians. So if I convert degrees into radians, 45 is just pi over 4. So pi over 4 radians is equal to 45 degrees. But this pi over 4, this radians, is the arc length only in the unit circle. So only if your radius is 1. So in the unit circle, when your radius is 1, this arc length is the same measure as the radians. So this would be pi over 4. So this arc length just got magnified 10 times. So it's going to be pi over 4 times 10. And that is going to be, divide these both by 2. That's going to be 5 pi over 2. So that's the measure of this arc length. So it's going to be 20 plus 5 pi over 2. And that's the perimeter of that ice cream cone shape. Okay, 8a. What is the cotangent of the inverse sine of 3/5? So let's draw a triangle. The inverse sine of 3/5, they're telling you that the sine from this position, this angle, this theta, the sine from here is 3/5, and the sine is opposite over hypotenuse. So the sine from this position is 3/5. And they want to know what angle that is, but we don't, because you use the inverse to calculate the angle, but I don't need the angle. All I need is the cotangent from that same position. So from this position, if the sine is 3/5, I know I'm looking at a 3, 4, 5 right triangle. This is a Pythagorean triple, or you could do Pythagorean's theorem to find it. This for this missing side. And now the cotangent from that same position, cotangent is adjacent over hypotenuse, so it is 4/3. So you kind of draw your own triangle and put theta wherever you want to. That's the position you're looking from, and then just find all the sides of the triangle. Okay, number 9, same kind of thing. Sine from this position is 3/5. Oh, this is the exact same triangle. So from here, the opposite over hypotenuse. Now they want you to look from phi. So phi is this angle right here. Now you're looking from here, so you got to make a triangle. The tangent, this is 5, this is going to be 3, this is 4. Tangent is opposite over adjacent, so it is 4/3. Okay, number 10, we kind of got to draw our own triangle. Angle of elevation for a ladder is 75 degrees. what height on the building does it reach if it is at 75? So our picture is going to look like this. So, not drawn to scale, but here's my 75-degree angle. So my ladder is this piece, 21 foot. It's anchored right here. It's extending till it runs into the building. The question is, how high is that? How high does it reach off the ground? Here's my ground, a 90-degree angle right there. So my triangle, this is the opposite. This is the hypotenuse. This is the adjacent. So the trig I'm going to use to find x, I'm going to use sine, because that's the ratio that uses the opposite with the hypotenuse. So the sine of 75 is equal to x over 21. Now if I want to solve for x, I just undo the divide 21. So times 21 times by 21. So 21 times the sine of 75 is going to be, this ladder is going to reach like 20.3 feet up the building. Okay, number 11, make a triangle. So let's draw perpendicular and altitude, and this is 4, this is 5. I want this angle. So if I'm looking from this angle, this is the opposite side and this is the adjacent side. So I'm going to use tangent. I'm going to do inverse tangent, because the inverse will give me the degrees of that ratio 5/4. So if I do inverse tangent of 5/4, that angle is a 51.3 degree angle. Find the cosine of 11 pi force radians. So first, 11 pi force, I know it's some kind of a 45 degree, I just don't know what quadrant it ends. So if you're starting to get good at radians, if you know that the force is a 45, here we go. This is, so if I divide all these into 45s right here, this is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4. So my angle, it's going to go around once, and it is going to stop in quadrant 2 right here. So here's my initial side. It's going to go around once all the way, and then it's going to stop right there. And it's a 45. So the trig that I'm going to do is not on this angle. I'm going to do the trig on the reference angle, and the reference angle is this angle. So I'm going to come down, make a 90. That's 45. So I know 45 is half of a square. And my square, okay, this is a -10, this is a +10, this is a -10, this is a +10. And my hypotenuse, my radius, is 10 square roots of 2. And what do they want? They want the cosine. So the cosine, they want the adjacent, a -10, divided by the hypotenuse, 10 square roots of 2. 10's divide out, so I got a -1 over square root of 2, and that is a negative square root of 2 over 2. You can't have a square root on the bottom, so you times the bottom and top by square root of 2, and this is it. Okay, number 13. 13 is almost the same question as this ice cream cone one we found back here. Number 8. So 13, they want the minor arc from B to C. So they want the shortest arc, this one, not all the way around. Okay, 30 degrees. 30 degrees, hopefully you can change that to radians real quick. 30 degrees is going to be pi over 6. So that is radians, and radians is arc length. So 30 degrees is equal to pi over 6 radians, and pi over 6, that's the distance, that's that part of the circle, if it was a unit circle. If this was 1 and this was 1, but it's not a unit circle. So I got to times that by 4. So it's going to be 2 pi over 3. The distance from here to here is 2 pi over 3. Okay, how long does it take for the minute hand to pass through 8 pi over 3 radians? Okay, 8 pi over 3. So, I wonder if I messed that up. I think I don't know. I think I did get it right. 30 degrees is pi over 6 radians, right? Okay, I think that's good. Now, the 8 pi over 3. So pi over 3, that's some kind of a 60-degree angle. So I'm going to do 60 degrees 8 times. So if I count, here's a 60, then 120 is a 60, then 180 is a 60. That's 162, 63 60s, 4 60s, 5 60s, 6 60s, 7 60s, 8 60s is right up here. It's going to end up in quadrant 2. So, if you just want to convert it to degrees, 8 pi over 3 times by 180 over pi, your pi's cancel. 3 goes into 180 60 times. 60 times 8 is 480 degrees. Okay, that's more than a circle. 400 minus 360 is going to be 120 degrees, which is right there. Right in quadrant 2, so 120. But now, minutes rotating on a clock 360 degrees is equal to 60 minutes. And then I'm getting 120 left over. Okay, on a clock, every 5 minutes is 30 degrees. So if we've got a clock, if we just look at from like 12 o'clock to 3 o'clock, that's a 90. So 1 o'clock and 2 o'clock, if I divide that 90 into 3 equal slices, every slice has got to be 30 degrees. So every 5 minutes is 30 degrees. So if I do 360, that's full rotation, that's 60 minutes. And then if I do 30, 60, 90, 120, that's what I need, is an extra 120, so I need 20 more minutes. So 60 minutes and 20 minutes, it's going to take 80 minutes for that to rotate through 8 pi over 3 radians. Okay, last one, number 15. Area of a triangle. Area of a triangle is 1/2 times the base times the height. And every triangle has 3 heights and 3 different bases. This triangle right here, if I draw an altitude from K to there, so the altitude has to go from a vertex, and it's got to hit at 90 degrees. So there is my 90 degrees. Now, I am looking at this triangle right here that's got 20 degrees, and there's the 90 I just drew, and this side is 8. So if I call this my altitude, this 14 is the base. So 14 is going in for the base. And my altitude is this piece right here. That is what I need. I need to know how tall this perpendicular piece is. So I'm going to use trig. And it is always going to be sine, because from the 20, this is the opposite. And there's my 90, so this is my hypotenuse. So the sine of 20 is going to equal x over 8. So if I solve for 8, or if I solve for x, my height is going to equal 8 times the sine of 20. So my height is going to be 8 times the sine of 20 degrees, and my base is 14. So if I punch that in, 1/2 times the base times the height, 14 times 8 times the sine of 20, I get the area of this triangle is like 19.15 units squared, whatever, feet squared.